This is for mathematical methods. It comes out of the VCAA 2019 exam 2, section 2, question number 1. So we have this function here, which has a domain of all real numbers. And I've asked to find its derivative. I'd like to have a look at it first to see what it looks like. So I've got it here, I drag and drop, and I can see that it is a graph that has two maximums, and then it's asymptotic towards x going to infinity and x going to negative infinity. So I'm looking for the derivative, so I'll take this interactive calculation diff first derivative, and I'll write that is equal to a minus 2x cubed minus 2x e to the minus x squared. State the nature of the stationary point at the origin. At the origin, it is a local minimum. One mark, one answer. Find the maximum value of f and the values of x which it occurs. Well, I think the maximum value is here, and this looks as if it's the same value, so I think it happens twice. So I will come up here and go interactive calculation, f max, and f max between negative infinity and infinity, correct. And the maximum value is 1 on e, and it happens at x equals negative 1 and 1. So maximum value is 1 on e at x equals negative 1 or 1. Find the values of d for which f of x plus d is always negative. So d is a vertical translation. If d is positive, that graph goes up. If d is negative, that graph goes down. If it's always going to be negative, well, it's negative, none of it's negative at the moment. So if it's negative, what I'd like is that this top bit to go below the x-axis, which means up here at the moment, it's at a height of 1 on e, so it needs to be moved down more than 1 on e. So d's got to be smaller than negative 1 on e. Because if it's smaller than negative 1 on e, if it's negative, it will move down. And if it's more than 1 on e, then it's going to move further down, and the graph will always be negative. Find the equation of the tangent to the graph at x equals negative 1. Okay, so I'll take my function, and I'll select it, interactive, calculation, line, tan line, at x equals negative 1. And okay, and that is y equals 1 on e. And that's because the tangent at that point there is a horizontal line. If I put the equation of 1 on e, you'll see that with the function and that line, it is tangential at that point. I'll just double check by analysis, sketch, tangent, and the tangent's got to be, sorry, I'll undo that. Can't undo that. Analysis, sketch, tangent at negative 1, okay, and that line was drawn at y equals 1 on e. Find the area enclosed by the graph of f and the tan line, correct at 4 decimal places. Okay, so if I've got my graph which looks like this, and that line, the area that's trapped is the area that's in here. It's worth 2 marks, so I'd need to write the area is the integral from negative 1 to 1 of 1 on e, that's the equation of the top curve, minus f of x, x squared e to the minus x squared dx, and that's going to equal keyboard, math 2, integral from negative 1 to 1 of 1 on e minus the x, execute. So 0.35681, which roughly equals 0.3568. And to also double check, I'm going to do analysis G cell integral intersection, accept that one. Come across to the next one, accept that one. That's the area, and we agree 3568. Beautiful. Square units. And lastly, let M and M be on the graph between 0 and 1. So M, N sits there. Find the minimum distance between that point and this point. So that's 1, E's about over here. And find the value of M for which it occurs. So there's two things being asked, the minimum distance and M. So the distance equals and M equals. Minimum distance equals an x. So that's going to be my answer. Just make sure I answer both of them. Okay, so the distance is going to equal the square root of, using the distance rule, E minus N plus 0 minus M. But N in terms of M is going to be f of M is going to be what M equals, and that's going to be M squared e to the minus M squared. So the square root of E minus. Hang on, that's not where it is. It's 0 and E. But that's okay. I can deal with that. It's still the same. It's the same process. E minus M squared e to the minus M squared squared. Now I'm going to use x instead of M. So I'm going to open up a bracket and square that bracket. And then plus, and I'm going to drag and drop that. So then I'll drag into here. So I've got E minus x squared, that squared, and that's going to be x squared. So that's the expression for the distance. If I take that answer and I interactive calculate the derivative, and I get that answer and I set it equal to 0 and solve for x. So my x value is negative 0.78, so over here, or 0, so that's the maximum distance, or 0.78. And I'm wanting this one here because it's between 0 and 1. So M equals 0.78, 3 decimal places, 783. And the distance will be my expression for distance, which is this one. Copy it, paste, and given x equals that, and that gives me an answer which is 2.511. Now, this is my expression for the distance. I'll copy that. I could have easily taken that and gone interactive. I want the minimum distance, calculation f min, where x goes from 0 to 1, because that's my domain. Okay, and I got the same two answers. Either of them's perfectly okay. So that is question number 1.